All right, can you guys hear me now on chat? So Jordan says, join the Zoom. It's all the same Zoom link. I'm going to tell you guys that right now. It's literally all the same Zoom link. I've not used a single different Zoom link. So if you guys have her email, yes, okay, great. Great. So chat people are taken care of. All right. This the camera in this computer, when I move the monitor, it comes unplugged sometimes, so I lose the microphone when it does that. I'll try to keep an eye out for that chat stuff if it does that again. Okay, guys. So you didn't miss anything. We're just talking about the test. So we'll do lo-fi. Did anybody have any questions about anything? Because I know it got distracted by the chat thing. Multiple choice, 50 questions. Okay. People have asked me how long, like you have the whole class period to do it, but most of my students will finish within 20 to 30 minutes. Okay. Yes. And if you want to sit here and mull over your questions for the rest of the time, you are welcome to. Yes. No, where does it say that? What? It literally no. Okay. I don't know. I think this is a misinterpretation. So hold on really quick. Let me. Where does it say that? In which announcement? Okay, I have to find it because I have all of my announcements on here. So we have posted on. So unit, please read unit exam rules. This one. Question banks administered as a Canvas quiz, not from the quizzes. So it's in the same format as the quizzes that you guys have online. It's that application, not from the Canvas quizzes. No. Question banks that I have made, like I said, it'll be like 10 questions in the question bank that I'll pull 9 from. Okay. So there's not gonna be a ton of variability between you guys, but you might get slightly different tests from one another. Question banks that are administered as a Canvas quiz using Lockdown Browser. All right, so not from past quizzes. You might have a couple of questions that came from the quizzes, a couple, but it shouldn't all be the same. I will say a lot of those quizzes that are on Canvas, a lot of the stuff is rewording of those quizzes, and it tests the same concepts, right? So as long as you understand those questions. Question banks administered as a Canvas quiz. Okay, does that clarify that for you guys? Okay, 50 questions, multiple choice. Any other questions about it? Oh, I did have a question. Yes. Oh, sorry. You're fine. Absolutely, you can sit where you're sitting now as long as I don't have any problems with this first test. Then we'll keep it going where we're sitting now. Yes. And then suppose people early because of that. But then let's just say people, how, if I go sit myself, how do I know that people are finished early? So, right. So that's where I'm saying if you guys want, if we finish in the test early and you guys want to start lab early, you'll have to wait in here to do that. However, if you were to leave, lab does not officially start till 7:15. You will not be counted late if you show up at 7:15. So if you did leave because you want a smoke break or you just want to go hang out at on cue or you want to go do whatever you do in between here and whatever, yeah, if you show up at 7:15, I'm absolutely going to catch you up on what you missed because you're not late. Okay. So we'll look at it that way, okay? But if you guys do, who in here would like to, if we finish early with tests, like to start lab early? Yeah, I figured as much, right? Because the late class. So hang out here after you're done with your test. Just wait and close your laptops, please, once you're finished. If you want to get on your phones and play on games on your phones, that's fine. But if your laptop is closed, I'll know you're done with your test. Okay? Can we agree on that rule? I usually don't do that, but this is a late class, y'all. I know you want to get out of here. Okay? So any other questions? Okay. All right, so it looks like we will be doing critical thinking questions first. We'll go over those first. Then we'll jump into the bacterial structures Kahoot. I'll probably also do my
gram-positive and gram-negative models at the same time, because I have models for those guys. We'll do those at the same time. Yeah. It only got 2 votes. The song, listen, okay, the song is not long. We'll do that first, okay?
It was pretty good. I saw it. It was pretty good.
Okay, so we'll do the song first. So if you guys didn't watch the song, and it sounds like most of you guys did, we're gonna watch the song first. So these were, for those of you guys who are wondering, I did all of the 8 topics for Unit 1 as examples for you guys, because you guys are responsible for Units 2, 3, and 4. So these are my baseline examples, right? So you guys are more than welcome to go above and beyond on yours, but these are basic examples of what I would expect. For pH theory, I made a video, okay? It is the most embarrassing thing I've done in a long time, but I made a song. I sung it to the tune. It was supposed to be to Teddy Swims' Lose Control, but you don't hear this background of the song because it didn't pick it up on the mic and I didn't do like an overlay. So it's like me singing in silence. And then when I replayed it, I realized it was silent during the guitar solo. So like, if you haven't seen it, you'll see what happens in the guitar solo. But let's just knock it out because everybody, it's goofy. Let's have a good time with it. Hi, everybody. I'm Lauren, a professor at Oklahoma State. It is on YouTube. In Oklahoma City, I teach introduction to microbiology. Yeah, I didn't want to put eye makeup on.
I thought it was for the style.
Yeah, sure. Yes. Yes. It's the mood. It's the vibes. I can't rap. I can barely sing. There are lyrics on YouTube, by the way, in the description. And how molecules themselves work. Whoa, whoa. Pitch is high or pitch is low. And I think that yourself just won't work anymore. Yeah, it'll take a huge toll on you. And soon you won't be here if you can't retain that control. Don't you know? Yeah, under 7 means acid, and that means too much proton. Affect all my molecules. Above 70 alkaline, that means nuclear proton. Mathematics, inverse log of proton concentration. 6 weeks of pH, so 10 to -2 means pH 2, and that means more acidic than what pH 5 says. Mathematics, water's made of H2O, but it's not static. H2O falls apart, becoming protons and hydroxyl groups in equal amounts, and that's pH 7, that is true. It's okay to laugh at it. I know it's goofy. I tried to make it seem that way. Thanks, it's not bad. The guitar solo is the best part. Just wait. So like I said, it was completely silent during this part when I rewatched it. And I couldn't just sit here with that. So it just goes back into the refrain. So if you guys decide that you want to do a song or something like that, you can put up like background slides that can cover all of the data that you're going over, but then also singing in the lyrics about it as well, so that you have all your bases covered. Yes. if you can just cover it. No, if you can do the music video and cover it in your lyrics, please, that is fine. Yes, that's absolutely fine. I love to see it. All right, so you guys saw the song, okay?
Good luck on the test.
All right, so we did it. So right, right. So we wanted to go over next over the critical thinking questions, correct? So we're gonna go to our announcements and pull up those critical thinking questions that I gave you guys. Again, bear with me while I find the announcement. So we have it's crunch time. It's got to be on this next page, right? You're there. Okay. So I'll try to make this a little bigger so we can see it better. All right, we're going to go through them one by one. Question 1. A patient of yours has an unknown blood infection, also known as septicemia. The lab performs a gram stain on a blood culture, and the results indicate a mixture of gram-positive and gram-negative rod-shaped cells. What answer choice best describes what is going on with your patient's blood cultures? So we know that we have a mixture of gram-positive and gram-negative cells. We're going to go through our choices and see which ones fit best what's going on. Is the patient infected with a species of bacteria that can alternate between gram-positive and gram-negative? So this is not our choice. Bacteria can't alternate between these two types of things. You either are gram-positive or you're gram-negative, and that's that. So you can't switch between the two, and this is why this is one of those extremely important major defining factors as far as determining the bacteria that's causing an infection. So it's not number 1. Number 2, the patient's blood culture contains 2 bacterial species, one of which is gram-positive and the other of which is gram-negative. This one makes sense, but I want to rule out the other choices, right? This result is not possible because there's no way for any culture to harbor both gram-positive and gram-negative bacteria simultaneously. So this one doesn't make sense, right? That's bonkers. We know that we actually already had this in lab. The samples that I gave you guys in that first lab where we did our streak plates, remember? That had a mixture of gram-positive and gram-negative in it. So this can't be it either. And then we have the lab likely skipped the alcohol step in the gram staining procedure. What would happen if we skip the alcohol step? What would our gram-negative cells look like if we skip the alcohol step? You guys know? It'll be purple, right? And we'll be going over that in detail, doing it hands-on in lab today. That's our lab today. Actually help with our understanding of how that gram stain is going to work in practice and help solidify this. But with the gram stain, we're going to be adding that crystal violet in. It sticks in peptidoglycan, but it's really going to get stuck in that thick peptidoglycan layer of our gram positives. All right, so think of that big scaffolding and how it can get trapped in there. When we fix it in place with the iodine, there's not enough in there in the thin layer of the gram negatives for it to get fixed in place. So when we rinse it with the alcohol, it just gets rinsed out of the gram negatives. But if we don't rinse it with the alcohol, it's going to stay there. So if we miss that alcohol step, everybody's purple. And you can't tell the difference. So this can't be the answer because everybody would be purple or positive. We wouldn't see a mixture, right? All right. So that's why question 2 is our best answer here. Or choice 2 is our best answer there. All right. Question number 2. A patient presents at your clinic with a persistent skin infection that has worsened despite treatment with antibiotics. You suspect MRSA, which is a strain of Staphylococcus aureus that is resistant to typical antibiotics. After several tests and culturing procedures, the lab results are back. The lab reports non-motile, irregularly clustered round cells. So we've got a whole bunch of info here already, right? We know it's called Staphylococcus aureus. What does staphylo mean? Irregular bunches, right? Be sure that when it comes to test time that you guys know the difference between staphylo and strepto, right? What's strepto? Chains, great. So staphylo, we know it's in bunches, and hey, guess what? Irregularly clustered. Interesting. All right, coccus, round cells. Interesting. You guys remember coccus? Beans, round cells. What are the rods called? Bacillus, great. So we know that is non-motile, it is irregularly clustered, it has round cells, and it grows on mannitol salts agar. Now, I do not expect you to yet. I will get to that. You will eventually need to know what mannitol salts agar is just off of the fly. But right now, I'm giving you what it is. What is mannitol salts agar? It contains high salt that selects for gram-positive bacteria, as well as a pH indicator if we use mannitol. All right. So we know it grows well on that. It tells us that it grows well on something that grows gram-positive. So what can we probably assume from this? Gram-positive. It grew on the media for gram-positive. All right. So which of the following would be correct? We've got a whole lot of choices that if you've been studying, these things don't relate to each other really, okay? So here's our choices. It is a firmicute. So this is our first choice, firmicute. So if we remember how we're classifying our eukaryotes or prokaryotes, same thing, are organisms that do not have a true nucleus or membrane-bound organelles, right? If we remember how we're classifying those guys that don't have organelles based on their envelopes, we have 4 groups that they fall into, right? We have the firmicutes. They're firm because they have the thick cell wall, right? We have the gracilicutes. I remember that one because if it has thick cell wall, we're gram-positive. The other the gram-negative, gracilicutes. That's how I remember those, okay? Firm, thick cell wall, gram-positive. Gracilicutes, gram-negative. That's how I remember those 2, okay? Then we had Joey Mendoza, my old boyfriend from middle school. That was a long time ago, back in the 90s, and he was cute. Mendoza cutes, archaic, old. So the Mendoza cutes, those guys are archaea, okay? And then we have the tenericutes. Tener is like Latin for tender. They're tender, they're soft because they don't have a cell wall. So those are our 4 groups. So if this guy, if we have said it grows on media for gram-positives, that lines up with number 1, doesn't it? Firmicutes, gram-positive. All right, our next choice, we got to rule out the other ones though, just to be safe. Peritrichus, what does that mean? Flagella all over them. So if you have flagella, you are motile. Flagella are used for motility. And we already know the lab said it was non-motile. So that means it does not have flagella. So it can't be number 2. Number 3, it would test positive for endotoxin. What kind of bacteria have endotoxin? Gram-negatives, exactly. So we already know it's gram-positive. It can't be gram-negative. It can't have endotoxin. And then our 4th one, its shape would be described as bacillus. It's round. It's coccus, right? So that's our first question. That's why choice number 1 would be, you guys see now how we're putting into play a whole lot of information about bacteria, but we really only had to figure out that it was gram-positive to answer the question, all right? So it's the same information for question 3. Our patient has MRSA. We think it is Staphylococcus aureus, and here's all the things, same exact conditions, but the question is different this time. Is the cell shape and arrangement consistent with your diagnosis? You thought it was MRSA, which is Staphylococcus aureus. And we said, is the cell shape and arrangement consistent? It says it's irregularly clustered round cells. Is that consistent? So is the shape consistent? Yes, right? The shape, it says round, that's coccus. The name is coccus. They line up. Is the arrangement consistent? You have staphylo, that means irregularly or grape-like clusters, irregularly clustered. So we have both. So that's going to be your answer number 3. This one, if you knew what coccus and staphylo meant, you should be able to figure out this one pretty straightforward, right? Again, giving you a lot of information, but all you really needed to look at was compare that name and know what staphylo and coccus meant, right? And I give you the definitions right there, all right? All right, the next question. Now your patient has a skin infection. Their symptoms are worse when we gave them antibiotics. So antibiotics should have treated bacterial infections. Antibiotics are used to treat bacterial infections, okay? Not viruses, not fungi, not anything else, bacteria. All right, so we gave them broad spectrum antibiotics. They're getting worse. What? So we swab their skin and we take a sample of it and we look at it with a simple stain. And we see large nucleated cells as the cause of the infection. So why didn't the antibiotics work? All right, so here are our choices. The causative agent was a eukaryote, and antibiotics don't treat that. That's going to be our right answer, right? So eukaryotes have our membrane-bound organelles, including a membrane-bound nucleus. So if we see large nucleated cells, those are going to be eukaryotic. And since antibiotics treat bacteria, do bacteria have nuclei? All right, so that's their defining aspect there. All right, our other choices, just so that we're clear, bacteria causing the infection are resistant to the antibiotics prescribed. It's not bacteria. We said the cause of the infection was nucleated cells. The patient would likely recover if we gave them more antibiotics. No, because antibiotics treat bacterial infection, and it is not bacteria. So this is really driving home that message. You need to know eukaryotes have a nucleus. The bacteria do not. Nothing else on here applies. And then our last choice, the causative agent must be archaea. Now, this is a little different, but do archaea have a nucleus? No, so we can also rule that one out that way. So it's number one. So as long as you remember that bacteria don't have a nucleus, for some reason you couldn't remember that eukaryotes do, you could use process of elimination here to eliminate 2 through 4. All right, our last question. A non-smoker patient presents at your clinic with worsening sore throat. The word for a sore throat, when you have inflamed throat tissue, is called pharyngitis. Antibiotics, remember, antibiotics only treat bacterial infections, and I've given that to you in this, have proven ineffective. All right, so you've given antibiotics, assuming that the doctor has given as many as appropriate. They're not working, and this person still has a sore throat. You decide to move forward by swabbing your patient's throat and sending it for microscopy. The lab says they look at it in the microscope, but they don't see any pathogens. What's going on? All right, so there's no pathogens visible in their light microscopes, but the patient seems to have a worsening sore throat, even with antibiotics. So here's our choices. The antibiotics killed the pathogen, but the person's just having lingering symptoms. All right, would they be getting worse though? Shouldn't be getting worse if we killed the pathogen. The patient is likely infected with a viral pathogen. Now, this one makes sense. Viruses are so tiny, they can be almost the size of our proteins. So this one makes sense. You wouldn't see this on a microscope. All right. In fact, when you have viral meningitis, and we look at this in your CSF will look perfectly clear. They call it aseptic meningitis because when they look at the gram stain of a patient that has viral meningitis, they don't see anything. So aseptic meningitis because they don't see any pathogens in there. All right, so that makes sense. Well, let's look at our other choices still. The patient is imagining their symptoms and the visible, you can see that they have visible inflammation. That must just be because they're imagining it so hard that they made it real. Now, this is an actual possibility. You can imagine having symptoms and then manifest physical symptoms, but the likelihood of that happening is very, very rare. It doesn't actually happen that often. And good luck convincing your patient that they're imagining their symptoms and made it real. So with treating this like this is the most likely scenario, it's probably viral, okay? The patient is probably lying and is actually a smoker still. Good luck with that one too. And then the patient's throat infection is probably caused by an archaea. So again, with the archaea, we would still see it in the microscope. They're basically the same size as bacteria, okay? So ours is the viral. Again, here we have other scenarios that if we try really hard, we could make them true. But what's the most likely answer here? That's that viral pathogen. And when you guys, you could even look at this question and be looking at it and be like, well, that's not really fair because some of the other ones could be true in other cases. Get ready for nursing school, y'all. I'm not kidding. Because literally every choice on your test will be correct in some scenario. You'll have to choose the most correct answer for your patient scenario that you're given. Yes. Absolutely. Yes. Yes. You'll have critical thinking questions like this on your exam. Your questions will range in difficulty from basic term type questions up to questions that are like these critical thinking questions. And students have asked me in the past, how many critical thinking questions will there be on the test? Treat it like the whole test will be that, and you'll be gold. Okay? It won't be the whole test. But will range in that difficulty. So it's kind of hard for me sometimes. Some of the questions will have some cross-topic thinking, but they won't be quite this complicated as these or as wordy as these. So there'll be some gray area there. Think of it as being a spectrum of those, but there absolutely will be some more complicated questions like this where I'll give you patient scenarios and you'll have to give me the most accurate or most applicable or most correct answer there. Make sense? And when you look at questions like this, where you could force the other choices to be correct, that's how every question on every test in nursing is going to be. I'm not trying to set you up for failure. I'm trying to prepare you for success here. So be ready for that. And trust me when I tell you that I have students come and tell me that I was not wrong about this stuff. I'm not trying to scare you about it. I'm trying to prepare you for the fact that this is not the hardest class you're going to take. It's not easier from here. So any questions about these critical thinking ones? As we walk through them, do they at least make sense when I'm walking you through them here now? Because when you guys get to the questions on the test, you're going to have that anxiety with you and you're going to be second guessing everything you're doing. Easier for you guys if you can know your information from your study sheets, like through and through. Take that anxiety away from yourself so that all you have to worry about is the test part of the anxiety, right? Okay, so the next thing that we wanted to go over was I believe it was the bacterial structures Kahoot. Let's do it. All right, library. All right, so you guys, when you're doing your projects, like I said, I made these, not the critical thinking questions, that was a separate thing, right? But the song and this Kahoot are meant to be examples of things that you guys could do for your own projects. If you want to use all of the features that Kahoot can have, you can't get those from the free version. But if you, for your project, want to do something with more features to it, let me know and I'll give you a pass to my Kahoot, okay? All right, so let's go ahead and get signed in on the Kahoot. Let's see. Do you guys want to do team competition or just regular? Anybody want teams? Okay, team sounds fun. We have one vote for teams. We'll do team modes. So I don't know how I want to divide it up. Let's do. Right, girls against boys. How does that sound, William? Let's have William be on his own team. So we will do, if you're online, let's get the teams up first. How about that? We'll get 2 teams. Yeah, Tommy says, yeah, girls against boys, let's do it. That would not be fair. All right, you poor guys. All right, so we will, let me get this down here. It says waiting for teams, but it's not giving. Oh, you guys. Yeah. I don't know. Oh, right. Okay, that's my problem. That was the problem. I'm like, why is it asking everybody to make a? Okay. Like, why is it doing that? Okay, let's do it the right way this time. Because I thought I didn't see that part of it. I just did it earlier today too, but you know it's late in the day. You guys gotta have to. Here we go. Okay, now let's try this again. 1 device per player. So I will give you 2 teams to choose from. Let me get the team set up first. Let's do Wolf and Unicorn. I'm getting rid of this one. Wolf and Unicorn. So what we will do is these first 2 rows minus William. Okay. First 2 rows minus William will be Team Wolf. William, you're going to be on Team Unicorn with the back rows. If you're online, just pick a team. Yes. Team Wolf, Team Wolf, Team Unicorn, all the way back, plus William. Trying to divide it up somewhat equally. You can tell my math is strong. It's not. I think they're different, like M&Ms, right? They say that the M&Ms are different colors. They don't taste. They tell me they don't taste the same, but they do. All right, guys. So we're set up with our teams. Everybody ready? Let's do it. Let me turn our little sounds up a little bit more. You're scared. It's not even worth. How often do you think about bacteria? It's just a poll question. We'll start off with this silliness first.
Oh, wait, we're supposed to talk about our team.
Well, I mean, you can talk with your team.
Always.
Always. There's not a right or wrong answer to this one, guys. A lot of people ask me if I'm not a germaphobe or something like that, but I don't really think about it that much. Yeah, who said never? Tommy? No, I have no idea. All right, so which structure aids bacterial motility?
I don't have it. Nobody does.
Yeah, it's not up yet. Now it is. Should be up now. So that was your team talk moment. If you guys want to converse with your teams, you can move in closer and converse with your teams. Great job. Look at you guys. Yay. All right, so we're only differing because of speed of answering the answers here. Okay, so that's the only difference here, but we both got it. All right, true or false? Bacteria and archaea lack internal organelles, including the nucleus. Pretty easy questions to start off with, guys, not gonna lie. True and do All right, so bacteria and archaea, both of them lack internal organelles, including the nucleus. So remember, these are our prokaryotes or eukaryotes. Those include bacteria and archaea, okay? Wouldn't it be fun? Team effort. Yeah, that would be fun. I don't know how the likelihood of that though. Yeah. Complete this sentence. Glycocalyx can form as which of the following? Team talk. All right, so our glycocalyx can form as capsules or slime layers. Glycocalyx, the sugar coating. That's what glycocalyx means. Glyco, the sugariness of it, calyx, the coating. So these are capsules or slime layers, right? You guys remember what those are used for? Adhering, evading phagocytosis, being eaten up by our white blood cells. That's what that is. And creating biofilms. That's what capsules and slime layers will do for us. Okay, here's our. All right, which shape is rod shaped? We just said this one too. Trying to throw the other team off, right? All right, so bacilli, great job. Remember how we're going to remember that? Cocci, C-O-C-C, those are round shaped guys, and those are the round shaped cells.
I'm sorry.
Bacilli, these are rod shaped. The L's in the bacilli word will remind you of the rod shape. Pleomorphic means many shapes, and spirilla is spiral shaped. All right, which bacteria form endospores? Little trickier. I'm looking for the names. All righty, so which bacteria form endospores? This is going to be Bacillus and Clostridium. Just basic kind of remembering which ones do that for us. So those are the ones that'll be our endospore formers. It'll have those in their names, okay? Good thing about Bacillus is that we also know that they form rod shaped too. It's a double whammy. All right, what is a tuft of flagella called? Oh my gosh, I just ripped my cell open. Well, that's just going to help me prove my point. Yeah, so it's lophotrichus, peritrichus, all the way around, amphitrichus at each end, monotrichus, one. So the tuft is lopho, okay? If you do not have flagella, you just don't have a flagella. You don't get a trichus name. You just don't have them. They're non-motile.
What is the green thing?
Lophotrichus, is that the green one? I have to go back and make sure now. Let me make sure I'm saying the right thing. Yeah, lophotrichus. That's going to be tufts. I don't know why this, when I think of lopho, I think of like lobo, and lobo is wolf, right? Pretty sure it's wolf. Am I imagining that? I'm not crazy. Anyways, I think of wolves. And wolves have tufts of fur on them, and that's how I remember that one. Oh yeah. Wolves. So there we go. We got wolves there now for us. So hopefully that'll help you guys remember. And your team wolf. What is the process of forming an endospore called? There's a term for it. Right. All right. So when you're forming an endospore, it's called sporulation. Right? When you're going from endospore to vegetative, that's called germination. It doesn't let me know. Sorry. I wasn't paying attention to the picture. I was worrying about my pokey sticks and balloons over here. So remember, endospores are, when you're a bacteria that can form an endospore, you will only form one, right? So you will turn into an endospore basically. So your cell, where you're being happy vegetative, these are the happy ones that are growing and multiplying. Suddenly you run out of your nutrients or your water or whatever it is, and you need to hunker down because things are going bad. So you'll turn into an endospore basically. As you're turning into an endospore, you become a sporangium. The endospore that you make, you only make one of. So this is not a replicative or way of reproducing, okay? You only get one from one. So we'll remember that too. So yes, they are little tiny round structures that these cells can make that are very hardy and resistant to conditions. All right, glycocalyx functions. I just touched on this one. We talked about this one. Let's see if you can remember which one it is. All right, great. Great job, guys. You were listening. The magic of listening. So adhering to surfaces, evading our white blood cells, our phagocytes, right? And then it makes it hard for them to bite onto us when we're all covered with that sticky stuff. And then forming biofilms, helping microbes build up on each other. Yeah, sticky. Yep. All right, which arrangement describes irregular clusters? Another thing that we talked about earlier. Key here thing, you better know your difference between your strepto and your staphylo whenever we get to the exam, right? I did give you half of the answer, yes. So staphylo, remember strepto, strip, chains. Okay. Palisades, that one is fence posts next to each other. Only the bacilli can do that. Tetrads, 4, groups of 4. All righty, Team Wolf pulling ahead. True or false? Endospores are metabolically active. True or false? Endospores. Was it on that? Okay. So I'll tell you what this is in just a minute. So that black sore on that hand that was showing, that's called an eschar. And it is formed whenever Bacillus anthracis infects the skin. So that's skin or cutaneous anthrax. That's what that's an image of. And Bacillus anthracis, does it form endospores? All the Bacillus species do. Okay, so that is an endospore forming guy. So what happened there was endospores got into an opening in the skin and formed that black wound. And that is what the wounds look like. It's black like that. I know it's gross. Okay, so true or false, endospores are metabolically active. Are the endospores actually metabolically active? No. Okay, it's false because they are not metabolically active. I'm going to point at things with sharp sticks now. They are dormant. They're completely dormant. They're completely inert. They're not dead, but think of them as being like even beyond hibernating. They're doing nothing. They're just housing their DNA. Once they come into contact with their nutrients and their water again, they come back to life in their vegetative forms. The vegetative forms are metabolically active and dividing. So remember, we talked about this with our progress of our disease. You are outside playing in, your yard, your wonderful expansive yard that I'm sure you have, and you step on a nail and it gets deep into your wound. You introduce endospores for Clostridium tetani, right? Clostridium tetani, and it gets deep into your tissues. Now those endospores will become vegetative, and those are what's causing the disease, making the toxin and leading to what we see with the pathogenesis or virulence. Those words are interchangeable. Okay. So another thing, on the exam, if you see a word like virulence and you are 99% sure that it wasn't on your vocab, like bolded words, it wasn't something that we necessarily specifically touched on, or you just want to risk it and go ahead and ask me, hey, I don't know what virulence means, raise your hand on the test and come be like, I'm not sure I know what virulence means, or I don't know what any term on the test means. Worst case scenario, what am I going to say to you? Well, it's one of the terms that we had to know. I might be able to reframe it in a way that'll help you remember that term. But with virulence, that wasn't a term we went over. So if you saw a question, it's like, tell me about the virulence related to endospores. You didn't know what virulence meant, you can raise your hand and come and ask me, and I'll come and tell you what it is. It's not intentional if I do that. I just thought that you knew what it meant because of words. Okay, so if that happens, because to me, it's words that I use all the time, and to you guys, they might not be obvious. That's just an example, right? There might be other words on there that might not even be scientifically related vocabulary. If there's vocabulary of any kind that you don't know on there, please ask. Do not hesitate to ask. It never hurts to ask, is what I'm saying. All right, complete the sentence. Bacterial cell envelope. What's the best choice here to go with the cell envelope? And I'm going to give my Graham's cell thing. Kind of goes with this. Very astute observation for those of you that are able to get an answer in. Includes the outer membrane. So here we have our other choices. Is the glycocalyx? Is it just the glycocalyx? No. Is the glycocalyx even included in our cell envelope? No. So your cell envelope includes all of the membranes and walls. I say with my sharp stick yet again, all of the membranes and the walls of the cell. So this will be that talking about the glycocalyx, everything but the glycocalyx basically on the outside of that cell. The cytoplasmic membrane, the cell wall, and the outer membrane if it has one. So it would include the outer membrane if you have one. Is it only the cell wall? No. Is it only the cytoplasmic membrane? No. So that brings me to my Graham positive and negative demonstration. Now, I was blowing up my balloon for my Graham negative and it's seen a little bit better days. So we're going to pretend like that didn't happen. But, okay, so with our Graham positives, imagine that the balloons in these examples are the cytoplasmic membrane, the membrane that contains everything in the cell. So in this blue balloon, cytoplasmic membrane, and our styrofoam cup represents the cell wall, okay? Gram positives, thick peptidoglycan cell wall. The white is the wall, right? And then the cytoplasmic membrane. Whereas with our Gram negatives, cytoplasmic membrane balloon, the cytoplasmic membrane, the white is the wall, again, very thin compared to this stuff, right? And then the pink is our outer membrane. So pink is membrane again on this one. Okay, so two membranes, white is the wall in the middle. Now, obviously, we've already had a catastrophe because my cytoplasmic membrane swelled up a little too far. I'm going to go back from that one, unfortunately. So, creepy paper is what I would call this. It's crepe paper. Anyway, so we have the 3 layers for our gram-negative, just the 2 layers for gram-positive, but that sturdy wall really gives that extra rigidity. So loud noise incoming, okay? If we put cells into salt, they will shrink, right? So you see when this guy shrinks down when we put him in salt, he's not maintaining his shape very well. This guy is. So this guy still maintains his shape even if we put him in the salt. Much healthier situation if you have that really sturdy, firm wall. Back to our firmicutes, right? So that's that, all right? You got the grams down, and we'll talk more about that in the lab when we do the gram stains. Question 13, true or false, archaea have peptidoglycan in their cell walls? Peptidoglycan. Vienna sausages. Yes, they do. All right, archaea. So this one, our bacteria have peptidoglycan cell walls. What do archaea have? Weird stuff, guys. We don't need to know what it is, but it's not peptidoglycan. They also have weird hydrocarbon molecules in their membranes. It's not normal phospholipid membranes. They are weird. They have similar structure, but the molecules that make it up is weird. All right, so we don't need to know the chemical makeup, but we know that it's not peptidoglycan. Question 14, what is the function of pili? Or singular pilus? All right, excellent. So most of us got this one, attachment and conjugation. So they're not for motility. Flagella are the only ones that are for motility, okay? But these guys are for attachment and conjugation. So we can attach to surfaces, but more famously, these guys are the sex pili, where they create channels between cells and allow us to shuttle DNA. That DNA swapping, just like we might have human DNA swapping if we had conjugal visits. Conjugation, okay? Yeah, now we remember. That's the pili. All right, last question. Double points, y'all. Which bacteria have variable shapes? Yeah, what'd you say? Variable shapes. We understand root words. This one's pretty straightforward. So yeah, so you guys got this one. We mentioned it earlier. Pleomorphic. Pleo means many. Morphic means shape. All right. So here's our final podium between the 2 teams. There's no 3. We only had 2. Get that loser out of the way. All right. Team Unicorn. Good job, Team Unicorn. Really good job, Team Wolf. Good team effort there, guys. Everybody did great. Really good job. So we have about 9 minutes left. I'm going to go try to hit a few questions on the eukaryotic discussion one, okay? So we're going to leave this one behind if I can find my cursor. There it is. I want classic mode. It should auto-populate you guys in here. Some of you guys might have to rejoin. You need to rejoin? Rejoin. What do you mean? Okay, for the McGraw-Hill stuff, it doesn't actually affect your grade. So it'll give you like 99 points out of 100, but all those points where it'll give you like a score on like chapter 1 McGraw-Hill. Sure, yeah, so even if you guys only did half the questions and then you ended up with a 50% or something on it, that'll give you like 50 out of 100 points. All of those McGraw-Hill things, the points are just there to show you your progress on that chapter, but all of those assignments altogether total as 0% of your grade. So actually your actual grade, when it totals out your grade and the math for your grade it's worth 0%. The grade points are there just so you guys can track your progress on them. Okay. But yes, if you go back to like the actual grade book, you'll see that they are 0% of your grade. Yeah. Good question though, because there's a lot on there on the grades. So completely optional. You guys don't have to do them if you don't want to. All right, let's go ahead and get going with this. We'll try to get in a few questions before we have to go to lab. All right, so each of these is a minute, and you guys are going to enter in answers, typing them in. I know, different stuff. How do flagella, cilia, and pseudopodia differ in structure and function among various eukaryotic organisms? Okay. I don't need a novel, but give me some examples. Apparently we don't get sound for this. Flagella, cilia, and pseudopodia. It does have a character limit also for those of you guys that are typed in. So on the question that asked about bacteria, I mean, how often you think about bacteria, Tommy has admitted that he did put never. He never thinks that's what he put for that. You guys were wondering who put the never on that one. It really was Tommy. Yeah. Always. I'm assuming he's okay. That's okay. If you didn't get yours in, it's not a big deal. This isn't for credit, right? So we have somebody that really put a lot of effort in. There's still time to put it in as we're kind of going over that. But flagella swims, okay. Some are singular, multi, and locations will be different. Okay, fair enough. Movement patterns will vary. This one's actually very accurate. So this one here, where our movement patterns will vary. So they're all involved in movement. With eukaryotes, they don't just use flagella to move. Eukaryotes are ones with the nucleus and the organelles. They will use structures like flagella, which are our long whip-like extensions. They move whip-like, whereas bacteria rotate and do runs and tumbles, right? Eukaryotes can direct their movement with their flagella. Cilia are tiny little hair-like appendages that move like oars, and they can filter the water for food and move water around them or other materials like our cilia do in our gut. But they can also be useful for moving the cell around itself. So tiny little hair-like guys. And then whenever we have our pseudopodia, those are our fake feet. So we can make extensions of our cells, extend it out, and then drag the cell along behind it. All right. So not bad. We're thinking in the right, yes, movement. Excellent answers. All right. Next question. What evidence supports the endosymbiotic theory for the origin of mitochondria and chloroplasts in eukaryotic cells? What is it about mitochondria and chloroplasts that makes us believe in the endosymbiotic theory? Gotta love it. That's why we don't do the tests on the Kahoot. We'll just say that. It'll just kick you right out. So whatever we don't get to today, whether it's the questions on the Kahoot or the other examples that I had for the projects, those are all posted on the Canvas for you guys to use at your own will. The questions are all posted on there. They'll only operate as traditional Kahoots, but you can still click through the questions and get the answers. Including the description of my beautiful gram-negative cell that has seen better days. Have you tried out Lockdown Browser on it?
Yeah, I have the app.
Okay. All right, what evidence supports endosymbiotic theory in these guys? Let's show them. All right, here we go. Organelle genomes, yes. So our mitochondria and our chloroplasts have their own genomes. That's correct. They have circular genomes, just like bacteria do. So they have their own circular genome. They have their own ribosomes that look like bacterial ribosomes. They divide independently. They also have a double membrane, right? So there's actually a lot going on with our mitochondria and our chloroplasts that look like bacteria. Likely they evolved from us eating up the bacteria, and that's what led to our organelles. And so that's what the endosymbiotic theory says. Our next question, name one phase of mitosis and briefly explain what happens during that phase. Just, you can use a couple words here. We don't need all phases. Pick one phase. What happens in it? I'll give you a hint, okay? Pee mat. The puppy goes pee on the mat, right? Pee mat. E-M-A-T. All right, so let's look at these. Oh, I didn't mean to do that. All right, here we have some, we have anaphase apart. Great, so we have anaphase apart. That's correct. Anaphase, we're pulling the chromosomes apart. Nobody put prophase. So P was prophase. That's the prep phase. Okay. So prep phase, that's where we're making our copies, consolidating down our chromosomes into that tight wound up chromatin. That's prophase, the prep phase. M is metaphase for PMAT, prophase, P, prep. M, metaphase, middle, lining up in the middle, right? We already said about anaphase, apart. And then telophase is another one that is missing here. Telophase, totally done was how I remember it, but getting ready to divide up our cells into those individual things. All right. Okay. Let's actually call this one quits. So I'm going to skip this one. But as far as what we have covered and what's coming up on the test, anybody have any questions? I know, right? No, don't worry about it. We're done. We're going to call this quits because we got to go up to the lab, right? We got lab at 7:15. So we're going to call this quits. If you guys want to finish this Kahoot quiz or any of the others that I have prepped for the unit projects that I had for examples for you guys, those are available on Canvas in that discussion area that I was showing you guys, right? Go to Canvas, click on discussions. Pinned at the top, we have the weekly reviews. If you haven't been looking at those, this is a good time for that. Unit 1 project examples. And in my reply to this are all of my examples for the major 8 topics that I chose to represent Unit 1, okay? Be sure you understand your study sheets well enough that you could explain each of the topics on the study sheets. All right. What? Yeah, smoke break time, guys. Right. Yeah, so that'll be individual. Like, yeah, you'll play it on your own time. And I'm pretty sure I have them set up. You can change the usernames, I think. You can change the usernames on them. It should be. If you have issues with it, let me know, but you should be able to change the username for it. Yeah. I hope so.
I've never met you.
I'm Lauren. Officially, yes. Nah. It's fun. I mean, I'm not gonna lie, it's expensive and I pay out of pocket for it, but it's worth it. Yeah. I mean, everybody has a lot of fun with it and it makes the quizzing part a lot more fun. I'm sure I could pull a leg if I really wanted to, but it's, yeah. So I could probably talk about that with Tiffany. Yeah. Yeah, it's fun. And I mean, so I pay for it out of pocket. It's not a big deal. Like, I pay for it. So I'm just like, I can say, you know, school's not exactly rolling in it. So I can say the school has the money for it. Yeah. It's a lot of fun. It works out. Yeah, nice to meet you too.